Okay, an enhanced deep learning model for classification and prediction of variants of COVID is the title of the work. So talking about the architecture. So we have two different architecture because the first question is what's the difference between these two architectural overview of the proposed framework. So the first one, figure 3.1, architecture for the design model, and the second one is hybrid model architecture. All right, so let me point to the hybrid part of it in the main architecture, which is this one. So if you can see my cursor here or my pointer, hybrid model. So let me first of all explain this one so that we'll be able to have a clear understanding of this the general architecture. All right, so now I'm talking about the hybrid. So because that's the meat of this research, that's the main thing that we are actually doing in this research. All right, so starting from the input image component here. So this one represents the data set. If you can see my pointer here, so the input image, and of course in the right up I think it's explicitly stated that we used chest x-ray images. Okay, so now the input to our model, before we input any image into the model, we have to pre-process it. So that's why we have input image and of course the pre-processing. So the pre-processing operations is just to do, or let me see what is pre-processing. It's the process of converting the raw image into numerical representation equivalent. All right, so then talking about pre-processing operations here, we have resizing to just to make the sizes of the images uniform. So, and of course in this case now when you look at the right up, you see 224. So that's because we are using a VGG16 and the mobile net as pre-trained convolutional neural network model. So that's the kind of size that they can accept, and that hence that 224 by 224. All right, so then we did normalization and of course augmentation to improve or to increase the diversity of the data set. So now after the processing, we pass the image to in parallel to all our parallel feature extractors, including VGG system, mobile net version 2, and of course our custom convolutional neural network. Okay, so the VGG system to extract global features, mobile net local features, and of course custom CNN task specific features. Okay, so now what they extract, they are just numbers, in this case matrix, right? So two-dimensional array of numbers. Then we apply global average pooling to each of the feature map, okay, to create a kind of one-dimensional array of number called vectors, so which will be very easy for us to really add together, called feature concatenation. All right, so here you have feature concatenation, that is the sum of all these vectors together. Then we pass those this representation into our dense layer for classification, and of course the activation function we apply here, because this is a multi-class classification, not binary classification, hence we use softmax activation function, which computes the probability distribution for the different classes. All right, so that's basically what this one is all about, the hybrid model architecture. Okay, so the word hybrid here is combining these different models together, the output of these different models together. So, and in this case we are doing the concatenation is done at the feature level. Okay, so that's the hybrid. Another one is clear. Then let's move to the general architectures. This is architecture for the design model. So what we actually did here is the representation of this one is that from the data set, just normal data, the preprocessing, and of course the output of the preprocessing, talking about all the preprocessing operation, resizing, augmentation, and things of that nature, we have the preprocessed data, so which is passed to, in this case now, it's important that we state it categorically, because this is the main difference between this architecture and the hybrid architecture. Now you have convolutional neural network, we have VGG system, we have mobile net version 2, and of course we have the hybrid model here. So what this one simply means is that each of these models, they were trained separately and evaluated separately. Convolutional network model was trained using the same data set and evaluated. The same thing with VG system, mobile net, and our hybrid model, which I've explained before. Now, after the evaluation, we compare the result, and of course, the best performing model is selected for deployment. So that's basically what this one is representing now. Convolutional neural network, trained, evaluated. VG system, trained, evaluated. Mobile net, trained and evaluated. The hybrid model, which is our model now, which is the main thing that we are doing this research, trained and evaluated. Then this is the comparison. You can see result comparison here. So this is where we compare the result. And of course, we selected the best performing model, which is our hybrid model now, because we have already carried out the experimental results show that the hybrid model actually outperform every other model. So we selected hybrid model as the best performing model, and of course we went for deployment. So after deployment, you see something like user interface, graphical user interface here, to enable the user to be able to access our model, to have access to the model. So, and of course, when you upload a particular chest X-ray image, then you pass it to the model, and of course, we have something like output here, so where the model actually act on the image, analyze it, and give us a predictive output here, which is either COVID variant, viral pneumonia, or maybe normal, and things of that nature. So that's basically what the architecture. So they are very simple architectures. So I think that's basically what the architectural designs are all about. If you have any other question, please feel free to push them to me. Thank you.